Okay, yeah. Okay, so today we'll start with loops, which will be one of the important building blocks of writing code in Python. So I'll start sharing the screen now. Just okay. Yeah. So here in this lecture, we'll discuss loops. Okay. So imagine that you want to do a large amount of repetitive stuff. Uh, I mean, okay, I guess if you are fans of the show Simpsons, you would see in the beginning Bart Simpson writing some punishment several times on the board. So imagine that you have some extremely long repetitive task where you have to do the same thing or similar things again and again. So we'll just take one example. Suppose that you have to generate the multiplication table for 5. So 5 times 1 is 5, and so on up to 5 times 10 is 10, is 50. Okay. With whatever we know of Python as of now, we can write print statements. We can. There's no conditional involved here. So if you have to multiply a given number by 1, you would say print n times 1 equal to n star 1, and so on. So if you have to write 10 times, then you will have 10 print statements. And this is the only thing that we can do right now. But in any reasonable setting, we would want to say something like, go do this similar task 10 times. Okay, so you have print n times something, and then that something changes from 1 to 10. So is there a way to abbreviate the process of writing this code instead of writing 10 statements? Imagine that you have to write 1,000 statements like this. So this is very tedious, and there should be an easy way to do it. And in all languages, there's some way to implement such a there are multiple ways to implement such a task. So the flow of the code will look something like this. The user inputs a number n, and then you start counting from 1 to 10. So you use a variable to count. You say I equal to 1, and then you check the current value of I. Have I printed 10 numbers? So if I is less than or equal to 10, then okay. So if I is greater than 10, then I'll stop because I've printed 10 times. If I is less than 10, what I'll do is I'll say print n times I. Okay, so in the beginning, it will be print n times 1. And then what I'll do is I'll update the value of I to I plus 1. Okay, so I now becomes 2. And you go back to the decision. Is I now less than or equal to 10? Yes, 2 is less than or equal to 10. So you go through the loop again. So you say it's true. So print n times 2 because I is now 2. And then I becomes 3. And then you go on to the decision back again. So you repeat this. At some point, I becomes 11. At that point, it's no I less than or equal to 10 is no longer true. So you go to the stop statement. Okay. So here is how you would model a repetitive task. You keep track of a variable which counts how many times you have repeated the task. And depending on the variable, you can decide, okay, yeah, do I need to, so depending on the value of the variable, within the body of the loop, you may do certain tasks. Here it is print n times I. Okay. So if you think about it a minute, if you're seeing this for the first time, I plays a dual role here. One is to count from 1 to 10. It is used to start at 1 and then increment one by one until you get to 10. And the other role that I place here is in this print n times I. Okay, so the current value of I is used to print some string outside. So in this case, it is n times I. So it was initially n times 1, then it is n times 2, and so on. Okay. So I place both roles. It can count from 1 to 10. And while doing that, it can also be used to do some task within the loop. Okay, and this whole thing is the true part of the code of the decision process is what is called a loop, because you can see a circular decision process there. Okay, the entry to the loop is the arrow from above where I is 1 and you have just read the input, and the exit is the false statement. So when the decision is false, you are no longer in the loop and you get out of the loop. Okay, so let's just see a simple Python code that implements the function that we have just talked about, or the code that we have just talked about. So you take input from the user and then cast it to int. So as we discussed in lecture 1, input will always give you a string. So that string you cast it into an integer. So that is now n. And we are now supposed to print the multiplication table of n. Start with I equal to 1. And this new statement that we are about to see is this while statement. Okay. So while it's true that I is less than or equal to 10, colon. Now the body of the print statement is, okay, print n times I. Okay. So this is print n, which is the value that the input, the user input, then X symbol, then I. So I will be initially 1, I equal to, and then the result in the multiplication table is supposed to be n times I. So it is n times 1, then you do I equal to I plus 1. Okay, so you will go back to the loop and check whether I is less than or equal to 10 now. I is now 2, 2 is less than or equal to 10, so you still enter the loop again. So you now print n times 2. And this goes on until I becomes 11, at which point the while statement, the condition in the while statement is false, and then you will get out of the loop and say print done. Okay, so the true part of the decision is the body of the loop, which is print and then I equal to I plus 1. Okay, so let's just see this work in the trinket. Um, okay, so if you have n equal to int of input, so I'll just enter the number or something, and then I equal to 1 while I less than or equal to 10. And at this point, I have to print the multiplication table. So I'll say n times I equal to n star I. Okay, and then for the next iteration, for the next time the loop executes, I'll just say I equal to I plus 1. And once I'm out, I'll say print done. So just let's run this, and let's say the multiplication table for 4. Okay, so it says 4 times 1 equal to 4 and so on. So you'll see, let me just simplify the print statement. I'll just, I'll just print n times I. Okay. So I'll just print 4. And what you have is the multiplication table for 4. Okay, so you have 4, 18, 12, and so on. Okay, and at the end, when I becomes 11, the while condition is now false, and you get out of the code and get out of the loop, and finally you say print done. Okay, so this is how a while loop executes. Okay, now let's go back to the slides. Okay, the general format of a while statement is there's an expression while expression colon and then a statement S1 which executes when the expression is true and as long as the expression is true, and then S2 which is the statement which you execute once the expression is false. So in our code, S1 was the bunch of statements print and then I equal to I plus 1, and S2 was the statement print done. Okay. So evaluate the expression. When the expression is true, then execute statement 1 and go back to step 1. So this is what is different between the if condition and the while condition. In the if condition, you test the expression. If it is true, you just execute it. Okay, and then you get out to S2. Here, you execute it and you go back to the and check whether the expression is true again once more. Okay, and then once the expression is false, you go to S2. So in our code, for example, when I equal to 1, you execute S1, go back and check whether I is less than or equal to 10. Okay, so I equal to 2 now. Again, you go to S1. I becomes 3. Again, you go and check whether the expression is true. It is still true. And this will go on for 10 times until I becomes 11. And at the point when I becomes 11, I is no longer less than or equal to 10. So you get out. The condition becomes false and then you get out. So the difference between if and while is if checks the condition exactly once. And in while you have this logic of going back and checking whether the expression is true. Once S1 executes, you go back and check the expression again. Okay. When the expression becomes false, then you get out of the loop. Okay, so let's look at a slightly more interesting example. Suppose you want to find out the maximum of um, a bunch of numbers that a user executes. So find the largest number read from the input, and the user enters many positive numbers and then designates the end of the input by entering a -1. So then we'll write the loop and then see how it works. So there is, yeah. So just like before, we say n equal to int cast of input, and then while n is not equal to -1, you read the remaining inputs. Okay. So now let's just see how the loop executes. Okay, so here is the code. And suppose the user inputs 4, 15, -5, and -1. Okay, so we'll trace through the loop and see what n takes, what values n takes, and how the loop executes. So initially int input, so the user has just input 4, and then you check, okay, 4 is not equal to -1. So the condition is true. So you enter the loop. Okay. Currently, you can see in the purple box that 4 is n is now 4. Okay. Now you read the next input. Okay. Which user has entered 15. So n now becomes 15 once you execute that, and you don't get out of the loop. You have to go back and check the condition again. So you check the condition again, n is now 15. 15 is not minus 1. So you enter the loop again. Again, you enter a number minus 5 that is read into n. N becomes minus 5, and you check the condition again. Minus 5 is not minus 1. You enter the loop again. Now the user enters minus 1. N is now minus 1. You check the condition, and minus 1 equal to minus 1. So not equal to is now false. And at that point, you get out of the loop. Okay, so this is how a loop executes. Okay, so I have a small quiz here. So one call to input every time the body of the loop is executed, and every input reads exactly one number, and that is cast to an integer. Okay, now let's slightly modify the problem and say I want to find the maximum of the inputs until the user enters minus 1. So initially I'll say that I'll keep track of the maximum number seen so far. So I'll say that, let's say, okay, I'll keep a variable max, which says that this is the maximum number seen so far. Initially, I have seen only one number. I'll say max equal to minus 1. And while the user enters numbers, if the new number that I see is greater than the previous maximum, so I have seen a bunch of numbers and I have kept track of the maximum number seen so far. Now the user enters another number. If that number is greater than the previous maximum, then I'll update it and say that, okay, max is now the latest number entered. So max equal to n. And now I'll read one more number until I see a minus 1. Okay, so I'll keep track of the maximum number that I've seen so far inside the variable max, and then you keep track of as and when the user enters, you see whether the number now entered is greater than the previous maximum, and then you update. Okay, so I have a small quiz at this point. Okay, so in the code just shown, which is about the maximum, how many times does the code run, the loop run if the input is 1, 3, minus 1?
Satya, you can go back to the
yeah, I can go back to
code
the
so that
the
code.
Okay, so yeah, I guess you go back to the code and you realize that when initially the user enters 1, so 1 is not equal to minus 1, so you enter the loop. Then the user enters 3, you go back to while, and 3 is not equal to minus 1, so you enter the loop again. This is the second time. Now the user enters minus 1, and the while condition is now false. So you enter the loop twice, and the third number entered causes the loop to exit. Okay. So yeah, three numbers are entered, but the loop executes twice. Now, okay. So now let's look at some terminology related to the loops. Each run of a loop is what is called an iteration. And in the example, yeah, just a minute. Yeah, so the three components of any kind of loops are initialization. First, you read a bunch of values, and then you check a condition to see whether the loop condition is true or not. So if the loop condition is true, in this case, n is not equal to -1, then you read the input. Okay, so you basically enter the loop, and at the end of the loop, you have the third component of a loop called an update. So initially you say I equal to n is the number input, and then you check the condition, and the third is yeah, you basically check, you cause the loop to execute again by reading a new input. So this is called the update step. And all three steps are important for yeah, for the proper execution of a loop. Now we just mention a theoretical concept called a loop invariant, which is important in understanding correctness of loops. So let's look at a loop invariant is basically a condition that is true at the beginning of a loop at the end and at the beginning of every iteration. Okay, so if you look at the loop for the maximum, you can see that there are two variables in a loop. In the loop, there's n and there is maximum. So there are two variables in the loop, and the loop invariant is based on the state of the variables inside the loop. So one of the things that you can always say is that whatever, so if you initialize max equal to n instead of max equal to -1, as I had done before, then I can make the claim that whatever the value of max is, it is the largest number that I've seen so far. Okay, so that condition is always true. So this helps you in writing and reasoning about the correctness of the loops. Yeah, so the invariant is that the max is always the largest number seen so far. And the loop should be written in such a way that the invariant is always maintained. So if max less than n, then max equal to n. So that statement actually makes sure that the loop invariant is correctly maintained by the loop. If you don't include that condition, for example, then the loop invariant is false. Max need not be the largest number seen so far, and that implies that the code you wrote is wrong. Okay, so the loop, so the invariant is that max contains the largest number. And now writing loops is one of the most tricky things in coding. This the kind of loops that we have seen are very simple, but there are a lot of common mistakes that people make when writing loops, and this is true even of experienced programmers, because depending on the problem, the loop can be involve very subtle logic. Okay. So one of the things is that the initialization condition may be wrong. So if you don't initialize the condition properly, then you could end up with yeah, you could end up with yeah, you could end up with errors. One of the quiz questions asks you to compute the minimum of numbers seen so far. Okay, and you can try that there will be a min variable, and if you initialize it wrong, then this might give you an error. Okay. Another very common mistake is to skip the update step. In the case of the code that we have seen just now, uh, we want to read the next n equal to the input. Okay, if that step is skipped, then the loop could go on forever, because the loop was you entered the loop because a certain condition is true, and you forgot the update, so the loop will forever be true. And so this ends up in what is called an infinite loop. And this is one of the most common and hazardous errors in coding. And if you're a fan of Apple and so on, Apple, the office in Cupertino, the official address is something like one infinite loop. So this is one of the most famous errors that you can encounter in coding. And when the update step is either skipped or it could be wrong. I mean, you did an update step, but the update step logic is not accurate. If that is the case, then you could end up with an infinite loop. And the third is the incorrect termination condition, right? You did the update all right, the initialization was all right, but then maybe the exit condition is wrong. So that could also end up in a incorrect logic. Okay, so I have a quiz for this. Yeah, so this is about oh, just a minute. I think maybe we should stop. Just a minute. I think the code is to be shown. So I guess I'll just halt the poll for now. Okay. So let's just look at the code and then we can. Yeah. So sorry. This is the wrong point to launch this poll. Okay. So we'll. Okay, Manish, are you there?
Yes.
Okay, I think we can skip poll 3.2.
Okay.
Okay. So let's look at a slightly different loop mechanism, which is also very common in Python. This is what is known as a for loop. The difference between a for loop and a while loop is that you commonly use a for loop when you know beforehand how many times to iterate. So for example, in the multiplication table, we knew that we had to print the multiplication table 10 times. Whereas in the maximum code, when we did not know, we had to compute the maximum as long as the user kept on entering numbers. And when the user enters a -1, you had to stop the code. So in cases where you know beforehand how many times to execute the code, then you use what is known as a for loop. Okay, so let's look at a simple example. We have to print, let's say, compute the sum of the reciprocals of the first 100 natural numbers. So you have to compute something like 1 plus 1 over 2 plus 1 over 3 and so on. Okay, so I'll initialize a variable. This is the initialization step in before the loop, and say the reciprocal sum is 0. And this has to be a float number because we are going to encounter numbers like 1 over 2, 1 over 3. So you can't keep the sum in a natural int. So we'll use a float to keep track of the number. Now, what I'll do is instead of a while loop, I'll write a for loop. Okay, you can also use a while loop for this, but there's a convenient way to count from 1 to 100 in Python. So the way you do it is you say for I in range. So range is what is called a sequence, and sequence goes from 1 to 100. Okay, so you go when you say want to say like 1 to 100, you say the range is 1 to 101 because 101 is the value beyond one beyond the ending point. Okay, so please keep track of this. This is something slightly tricky in Python, that if you want to go from 1 to 100, you have to say that the range goes from 1 to 101. Okay, so that's the for loop. You say for I equal to range 1 to 101 colon, and then the body of the loop is similar to what you would write in a while loop. You say r sum equal to r sum plus 1.0 divided by I. Okay, so you say r sum equal to 0 plus 1 divided by 1. Then in the next iteration, you have r sum plus 1 divided by 2 and so on. Now, if you are a bit observant, you'll see that there's one big difference between while and for. In the while loop, I'll go back maybe a couple of slides. In the while loop, we had to write the explicitly the update step. You had to say n equal to int input, or in the multiplication table, we had to say I equal to I plus 1. If you see the for loop, this is the for loop we wrote. We did not have to write any explicit update step. The update step is taken care of by the for loop itself. So when you say range goes from 1 to 101, the step of the task of doing I equal to I plus 1 is already taken care of. So this is the convenience that for loop gives you. So in occasions where you know beforehand how many times to execute the loop, then all you need to do is I'll say range from 1 to 101, and I just need to specify the body of the loop, and the update step is already taken care for me. Okay, so the general form of a for loop is for variable in sequence, where sequence is something like range 1 comma 101. You do the statement. Okay, and the way the logic works is, okay, I think I have a question. No, okay. And the way you execute is for variable in sequence, first evaluate the sequence to get a list of values. Okay, so in our case, it was range from 1 to 101. And then if there are more values in the sequence, then go to step 3. Okay, otherwise exit. So once you're done with the sequence, you have gone from 1 to 100 and now you are at 101, you exit the sequence. Okay, so always bind the variable to the next value in the sequence. Initially it is I equal to 1, then it is I equal to 2, I equal to 3 and so on until you reach I equal to 101, and at which point you exit the loop. Okay, so first evaluate the sequence to get the sequence from 1 to 100. And if there are more values still remaining in the sequence, then update it and execute this body once again. Okay, so if you have something like range 1 to 5, let's try to step through the code and see what it's doing. So if you say range from 1 to 5, the evaluation of the range expression will give you a sequence which contains 1, 2, 3, 4. Please note that 5 is not included. So now I is repeatedly, so I starts from 1, then it goes to 2, then it goes to 3, then it goes to 4, and so on. So initially I equal to 1, you enter the body of the loop and then you execute. Okay. And then once, so R sum is now 0 plus 1. And now bind I to the next value, that is 2. So R sum now becomes the previous value, which is 1 plus 1 upon 2. Okay, so this is 1.5. Then again, I becomes 3. You enter the loop and you add 1 upon 3 to the previous value, 1.5 plus 1 upon 3. So it becomes 1.833 and so on. Again, you take the next value in the range, which is 4. So you enter the loop and say previous value plus 1 upon 4, which is 0.25. And so R sum now becomes 2.0833 and so on. At this point, you are done because the range contains only values 1, 2, 3, 4. So now the remaining part of the range is empty. So there are no more values that I can take, and you just exit out of the loop and print the reciprocal sum of the first 4 integers. Okay, so the range, the general form of range is range of SED, and S is the starting point, and E is not the ending point. E is something like one beyond the ending point. Okay, so S is the starting point, E is like the ending point plus 1, and D is the difference. Okay, so initially it takes S. In the previous example, D is just 1. So you have S, S plus 1, S plus 2, and so on. But in general, you can skip 2 at a time or so, something like that. So you can say S, S plus D, S plus D plus D, which is S, S plus 2D, and so on up to S plus KD. Okay, and this goes on until you hit E. So at the point you hit equal to E, you get out of the loop. Okay, so E is one past the ending point of the loop. And if D is skipped, in the previous example, we just wrote range of 1, 101. So there was no D. So in that case, D is taken to be 1. Now, Python also gives you the convenience that you can even skip the starting point. You can just say what is the ending point plus 1 in some sense. In that case, S is taken to be 0. And this is another thing to note, that this may not be what you expect. We may expect that if the S is skipped, then S has to be 1. But Python adopts the convention that if S is skipped, then you start with 0. Okay. So the most common way in which you write for loops would be using 2 numbers, which is S and the number beyond the ending point, okay, which is E. So far in the lectures, we have seen how to take a user input, how to print messages onto the screen. Now we have seen Boolean expressions and conditional statements, and we have seen simple while loops and for loops. So while loops, you have to put in the explicit update statement within the body of the loop. And in for loops, you just say, okay, what is the range? And then the update is taken care of automatically for you. Now, immediately in the course, what is left are nested loops and functions. So before that, yeah. Yeah. So once, yeah, at this point, are there any questions? I'll just just give me a minute. Yeah. At this point, are there any questions about for loops and while loops? Um,
No questions? That's pretty strange.
okay, so before we go on, I think I'll show a bunch of coding things and then ask Manish, can we have a poll based on a question that I ask?
Which one?
So I'll just make I'll just code a bit and then make some change and then ask people, okay, like what do you think will happen?
Okay, sure, we can do that.
Sure. Okay. So I'll just stop sharing the slides and go back to the trinket. Okay.
Okay.
Okay. So we have the while loop, and I'll just is there a way to? I'll just delete this for the moment. Okay. Actually, I can. Okay. I'll go to a for loop example. Okay. So I'll say, yeah. Let's say that I want to compute the maximum of, let's say, 7 numbers. So this is a fixed number of elements that I have to compute the maximum for. And so I'll say, written a small for loop here. Am I audible?
Yes.
Okay. I've written a small for loop here. I'll just, is this visible? I hope the code is visible on your screens. Now, before running the code, I've just started running the code. I've not executed it fully. How many times will this loop execute?
Let me put a poll. Give me a second.
Yeah, yeah. And the possibilities are 0, 7, and 8.
We still don't have answers from 5 or 6 people. Please answer.
Yeah, please, at least give a guess. I mean, this
Yeah.
is not graded. Okay, so the answer is 7, because as I just mentioned in the slides, if you say range goes from 1 to 8, then it will execute for 1, 2, 3, 4, 5, 6, and 7. So at 8, it just exits out of the loop. So let's just run it and see. So I've started running it, and I'll just say 2, 3, 4, 5, 6, and 7. Oh, yeah, so this just forgot to print the max. So I'll just run it again. Okay, let me just, and so it printed that the maximum is 7, which is, so the logic is correct. And we were more interested in seeing how many times the loop executes. So it goes from 1 to 7 and not from 1 to 8. Now, if I had a third argument, let's say 2, now it goes in steps of 2. So initially it starts, so enter a input a number. Initially it starts with 1. Then the next number is not 1, it will be 3. Okay. So it goes from 1, 3, 5, 7, and then 7 plus 2 is 9 is greater than 8. So you get out of the loop. So if you say 2, then the loop executes for I equal to 1, I equal to 3, I equal to 5, and I equal to 7. It should execute only 4 times. So let's try that. So if you enter this, okay, you have 1, 2, 3, 4, and now it should stop. Yeah. So it exited saying that the maximum number seen so far is 4. So you can play around with this. And one thing to note, as I said, is this. So if I, inside the code, I'll just print I. If I just say range 8, I goes from 0 to 7, right? So initially it is 0, and then enter a number, I'll say 1. Then I becomes 1, enter a number 2, then I becomes 2, 4, 5. Okay, now I become 7, I'll enter the number 8, and at this point I becomes 8, and yeah, at this point I've exited the loop, and the maximum number seen so far is 8. Okay, so if you put only one number, instead of counting from 1 to 7, it actually counts from 0 to 7. So there are 8 numbers here. Whereas if I put 1 to 8, it prints from 1 onwards. So 1, 2, 2, 3, 4, 5, 6, 7. And at this point, we should get out of the loop. Yeah. So the maximum value printed is 7. Okay. So these are the different ways in which you can use range. You can use range with only one number, in which case you count from 0 to that number minus 1. Another is you can use it with two numbers, in which case you start from the first number. You start from 1 and then go up to the second number minus 1. Or you can also do it with 3, in which case you take steps, you bound by steps of the third number. So if I put 2, I'll say 1, and the next number will be 1 plus 2, 3. next number would be 3 plus 2, 5, and so on. Okay. The most common usage is a two-number pattern where you have the starting number and one beyond the ending number. Okay. So please take care of this. Please keep this in mind that in Python, the range goes from start to the ending number plus one in some sense. Okay, because even when I code, I have to look this up because I always get confused between is 8 the last number or is it one beyond the last number? So in Python, it is one beyond the last number. Okay. So now let's look at nested loops. So this is loop within a loop, and there's a fantastic example. So basically, you have an outer loop, and within that you know that you can put any statement within the body. So what happens when you the statement within the body is itself a loop? Okay, and so there's a fantastic example that of a nested loop in real life, which is a clock. Okay, so let's say we have a clock with a minute hand, an hour hand, and a second hand. So you know that the minute hand goes from 0 to 12 to 12, and then for every so many times that the minute hand rotates, the hour hand rotates by certain degrees, and then the minute hand is also controlled by the number of rotations of the hour hand. So you can think of the second hand. So you can think of the hour hand as the outer loop, the minute hand as an inner loop within the hour hand loop, and then the second hand is an innermost loop within the minute hand loop. Okay, so 60 seconds constitute a minute, 60 minutes constitute an hour, and so on. So similarly, even in normal, in the usual stopwatches, you can see this loop within a loop structure. So you can say that within the hour loop, the minute loop is an inner loop. Okay. So this is a nice example of a nested loop structure that we are used to in real life. Okay. Similarly, in programmatic situations, we may need certain inner loops. And we'll now look at a few basic examples of code involving nested loops. Okay, so let's start with a very simple example. Write a program that displays the following pattern. So this is the first row contains 1, 2, 3, 4, 5. The second row contains multiples of 2, which are 2, 4, 6, 8, 10. The third row contains multiples of 3, which are 3, 6, 9, 12, and so on. So every row n contains all multiples of n from n times 1 to n times 5. Okay. So now before we launch into the code, let's just sit back and look at what it's doing. So initially we have to print 8 rows, and in each row we have to print the multiples of that particular row index, going from row index times 1 to row index times 5. Okay, so we have to print 8 rows, and within each row you have to print 5 columns. Okay, and when your code has this kind of a description that you have to print a certain number of rows, and within each row you have to print a certain number of columns, it naturally comes out as nested loop structure. Okay, so let's take a look at that. Okay, this should be 5 columns. Okay, so we have to print 8 rows. So this goes from, the range goes from 1 to 9, right? Because 9 is 1 beyond 8. Okay, for each row, what do we have to do? We have to print 5 columns. So J should go from 1 to 5. So we express it as range 1 comma 6. Okay, so I is the row index and j is the column index within the row. So oh, okay, I guess, are the slides visible? So that I can reintroduce the. Okay, so I'll just go back. So we were introducing this concept of a nested loop. A nested loop is a loop within a loop. Okay, and as I just mentioned, that classic example of a loop within a loop is a clock, where you have an hour hand which goes um, 12 times in half a day, and then within each rotation of there will be several times that the minute hand rotates and so on. Okay, so we introduced this problem where we want to display a table containing 8 rows, and each of the 8 rows contains 5 columns. So the row is each row is printing the multiplication table up to 5 of a particular number. So if you are looking at the third row, then it's printing the multiples of 3, 6 up to 15. Okay, so 3 times 1, 3 times 2, 3 times 3, 3 times 4, and 3 times. So this is the problem at hand. We have to print 8 rows, and within each row print multiples of that row until from 1 until 5. Okay, so now let's look at the code. So since we have to print 8 rows, what you do is start from 1 and print up to 8. And this is a predetermined number. We know there are 8 numbers to print. So one way to do it is using a for loop. So you say that for I equal to range from 1 to 9. Okay. Now within each row, you have to print 5 columns. And again, it's a predetermined number. You can print 5 columns using for j in range 1 to 6. Okay. And what we are going to do is within each row I, within each column j, the number to be printed is I times j. So in row 1, for example, the numbers to be printed are 1 times 1, 1 times 2, 1 times 3, 1 times 4, and 1 times 5. Okay, so for each value of I, j will go from 1 to 6, 1 to 5, sorry. Okay, so the inner loop executes more number of times. And then for once it executes 5 up to 5, then the outer loop prints. Okay. Okay, just let's look at how it works in the trinket. So I'll say for I in range 1 to 1 to 9. So there are 8 rows to be printed. And for J in range from 1 to 6, print I star J. And then because I want spaces in between, I'll just say okay, so let's just run this code. Oh, I think there's this Python 3 problem. Okay. Okay, right now let's just worry about printing numbers in one line at a time. Okay, so initially I goes from range 1 to so this is the for I equal to 1, these are the numbers that will be printed. Okay, similarly for I equal to 2, j will go from j equal to 1, j equal to 2 up to j equal to 5. So you print 2 times 1 up to 2 times 5. Then you go to the outer loop again. So you I equal to 3 and j goes from 1 to 5. So you print 3 times 1 all the way up to 3 times 5. So this goes on until I becomes 8. And at that point, you have 8 times 1 going up to 8 times 5. So this is how it works. So I changes slower when compared to J because the inner loop is executed 5 times before the outer loop gets to execute one more time. So in the hour hand and minute hand example, J is more like the hour hand, is more like the minute hand. It turns more number of times, and every so many rotations of the minute hand, the hour hand rotates once more. So this is like J executes from 1 to 5, and then you go to the outer loop, and there you say, okay, I can print, I can increment I to the next element in the sequence. So this is how a nested loop works. Hmm. Okay, so there may be a slight confusion in the, so in the slide, just ignore this end equal to space for the moment because there may be a Python 2 versus Python 3 issue. I'll update the code which works with Python 2. So I'm ignoring the Python 2 versus 3 issues here. Okay, so now let's look at a slightly different pattern. For I in range from 1 to 6, and for j in range from I to 2 star I. Okay, so how do you do, what do you suppose will be printed? So before we start looking at the execution, let's try to predict what's going to happen. So I will go from, so I goes from 1 to 5, and let's say I is 1. Then j goes from 1 to 2, right? So the range for j when I equal to 1 is 1 comma 2. So it executes only once, right? So you have print j. So in the first case, it will just print j once, which is j equal to 1. Now you go to the outer loop again, and now I is 2. And at this point, the range for j would be starting from 2 and ending up to 2 star 2, which is 4. So J has basically range 2 comma 3. Range is basically 2 comma 3. And then you go to I equal to 3, and then J goes from range 3 to 6, which means 3, 4, 5. Okay. So what will be printed here is when I equal to 1, it will print only 1 because it is range from 1 comma 2. When I equal to 2, it's the J's range is range 2 comma 4. So it will print 2, 3. When I equal to 3, J's range is range 3 comma 6. So it will print 3, 4, 5, and so on. So you will have a triangle like structure being printed. The columns, the initial column will be 1, 2, 3, 4, 5. And then in each row, it will print, in each row n, it will print n consecutive integers starting from n. Okay, I guess. Yeah, so there's a small quiz, poll 12. So I'll just go back to the slide. So you can take a look at the slide and then this one is a bit tricky. Please think a minute before you answer. Okay, I think I can give maybe 20 seconds more. Yeah, I think we can stop right now. Oh, okay. Yeah, sorry. I think there's a small mistake in the poll result. So the correct answer is the third one, which is change the inner loop from range 1 to I plus 1. So what I want is in each row of the output, I want the numbers to go from in each row of the output, I want the numbers to go from 1 through I, right? So it's J that should be controlled. So basically we should be worried about the inner loop. So the value of J is to be controlled because J is what ultimately controls what is being printed in each row. Now, so there are now two possibilities. which is the second possibility is change the range in the inner loop, that is the value of j from 1 to I. And the other is the third choice, which is j equal to j ranging from 1 to I plus 1. And the question clearly says that I want to print values from 1 through I, both inclusive. So if I want to print I itself in the row, then the range should go from 1 to I plus 1. Okay, so the third answer is what is correct. I think in the poll, so the last answer is um, not correct, because the outer loop controls I, and in our thing, I is basically, it has to print a fixed number of times, maybe 7 or 8 or whatever it is. So that logic doesn't have to change, but the logic of j has to change. So in these conditions, please think through, like, what is the output going to be, and which is the which loop is uh, to be changed in order to change the output. So even though I said that the contents of the row has to be changed, ultimately, if you think through the logic, it is j that controls what is being printed in the row. So you should change the inner loop. Okay. Was that clear? Any questions on this one? Okay, so I hope this is fine. Okay. Now you can change the patterns to your liking. For example, if you want, this is an example that needs to be changed a little bit based on the Python 2 versus Python 3. If I can give an extra argument which gives you control over what is the spacing character that is printed in between. So instead of a blank space, if I need to print a full stop or a period, then I can give it as an extra argument in the code of print. Okay, so now let us look at two ways to control the execution of a loop. Right now, we have seen that a for loop starts executing from the s value and goes all the way up to e minus 1. Okay, is there any way to control and say that certain values I have to skip or something like that? Okay, Python, just like other languages like C or Java or any of these languages, provides two mechanisms to control the execution of a loop. The first is what is known as a break. So let's look at what is break and what's a natural situation where you would like to use a break. Okay, and this is the use of break is to exit a for loop forcefully. Okay, so for example, for the for loop, we have predetermined that we have to execute it up to 10 times. But suppose in between the user enters an invalid value. So in that case, you say, okay, I'll just stop my execution. There is an error and get out. Okay. So so the idea of a break is if you're inside a for loop or a while loop, when you encounter a break, you just get out of the out of the loop immediately. Now there is a question in presence of nested loops. Which loop? So there are, let's say, two for loops: one outer for loop, one inner for loop, and inside the inner for loop you have a break. So the logic is that you break out of the smallest loop. So the innermost loop you get out. So break out of the smallest enclosing for or while loop. Okay. So let's look at a small program, a scenario that we are interested in. This is a program to sum 100 integers entered by the user. But if a user enters enters any negative number, then you have to exit out of the program. Otherwise, the normal condition is that the user enters 100 numbers. Okay, so the code is supposed to do this. Suppose the user keeps on entering non-negative numbers, then you wait until 100 numbers are entered. Or if the user enters a negative number, you immediately say, I'm done, and get out. Okay, so how do you implement this logic? So you keep track of a sum variable to keep the sum, and it's a sum of integers, so the result will always be an integer. So you keep sum equal to 0, and then to read 100 numbers, I can use for I equal to range 100. So just recalling once again, range 100 means you will go from 0 all the way up to 99. So there are 100 numbers in that going from 0 to 99. So you will read exactly 100 numbers. So for I in range 100, you read whatever the input user has entered into a variable called value. Now, if value is non-negative, if value is either 0 or it is positive, you can continue adding it to the sum. But if value is negative, immediately you have to stop reading any further input. If any value entered by the user is negative, you just stop and get out. Okay, so if it's a negative number, you don't have to go through the loop anymore. So how do we enter this? So you say that if value is less than 0, then you break. Okay, and what break does is it gets out of the innermost for loop and just, so here there's only one for loop. So it gets out of the innermost for loop and gets out of the and continues execution. In this case, there are no further statements, so that's it. But if value is greater than or equal to 0, then you don't execute this if condition, if statement, and you just say sum equal to sum plus value. So as long as the number entered by the user is positive or or 0, you always add it to the sum. But at the moment, at the very moment the user enters a negative number, this condition becomes true if value less than 0, and then you execute a break statement. Break statement will say that I'll get out of the for loop, so no further input will be read. At the end, you can print the sum. Okay, so the break statement causes execution to exit out of the for loop, and you will get out of the for loop and just print the last statement, which is print sum. Okay, now often you can write so any code where you use break, you can write it in a slightly different way where you avoid the use of break. Okay, so there's always a question of whether to break or not, and this is always up to the coder. So use of break sometimes can simplify the exit condition from the loop, but it could also make the code a bit harder to understand. Because if you look at the previous code, you have to, initially it looks like, okay, let's just look at the previous code. Suppose you're reading somebody else's code and you see for I in range 100. At that moment, you realize, okay, I'm going to take 100 inputs. Okay, that's what's going to happen. But then you read the code and you realize that that's not exactly what happens. The moment any input is negative, you actually exit out of the loop. So what the loop does is read either 100 positive, read either 100 non-negative numbers or read up to the first negative number that is input. So the logic is not clear from just looking at range 100. You have to look through the whole loop to see what is being done. Okay. So it can make the code a bit harder to understand, but um, so if the loop terminates in at least two ways. So for example, in the previous example, we saw that the loop has two ways to terminate. One is that 100 non-negative numbers have been entered. Another is the user enters a negative number. So if the loop terminates in at least two ways which are sufficiently different. Now this is up to the programmer's judgment. What is meant by sufficiently different? So if it is sufficiently different, then you can consider using one of the conditions for the loop and the other is break, other for the break. Okay, so if there are two similar conditions, then put it in the loop. If there are more than one condition where one is substantially different from another, then you kind of decouple the logic, make one into the loop condition and the other into the break condition. Now, this is somewhat philosophical, and different programmers take a different view on this. I always prefer to have one condition in the loop and another condition to break out of the loop. Okay. So we'll also take a look at continue statement. Now the continue statement is used for skipping an iteration of the loop. Okay. In this case, the loop is not exited. So for example, read 5 integer inputs from a user, whether they are positive or negative, but sum only over the positive inputs. Suppose your problem is given of the following, in the following way. Then break will not work. What we have to do is, if the user enters a negative number, then you just ignore the negative number. Okay. And for this, what is known, the statement that we can use is what is called a continue. Okay. So we can say sum equal to 0. And then let's say that I have to take 5 numbers. So for I in range 5, and then I take the user's input into a variable called value. If value is negative, so here is what is different. If value is negative, earlier we just broke out of the loop by using a break statement. Here we say that okay, the user has entered a negative value. I don't want to take any, I don't want to exit the loop. I just want to ignore this number. So I will not add it to the sum. So the way I'll say is continue. Continue means that it will immediately go back to the next I value. Okay. So in case the input is 5, 6, minus 2, 3, and so on, what it will do is it will take 5, add it to sum. It will take 6, add it to sum. It will take minus 2. At that point, it realizes that minus 2 is less than 0. So it will say continue, which means it will go back to the loop without adding it to the sum. So continue means you go back to the for condition directly without bothering about what is remaining in the loop. So this is different from the break, which causes the loop to terminate immediately. Continue actually does not cause the loop to terminate. It actually says, okay, now go to the next value in the loop. Don't execute the remaining part of the loop for this I. So for example, here's a condition like, suppose you want to sum only over all odd values from 1 to 10. So you say I equal to 1 while I less than or equal to 10. Then you know that it's an even number. Okay. If the number is even, then you don't want to add it. So you say continue. So continue means you will go back to the loop and so on. So think about this code for a minute. Continue means you will skip the end of, you will skip the loop, remainder part of the loop, and just go back to the while condition. So if you run this, what will happen? Okay, so one important thing to notice is that the while loop should have something like an update step. Okay, so if you say that, if you say continue at this point, what happens is that, let's say I equal to 0, I equal to 2, then 2 mod 2 is 0, and you just say continue. Continue will immediately go to the next part of the next iteration of the while loop. But you have not updated I equal to I plus 1. You set continue before anything else could be done, right? So at this point, if you say continue, then I will be permanently stuck at value 2. Okay, so make sure that the continue does not pass update expressions for while loops. Okay, for loops, the update is taken care for you. So then this does not any problem. But in the case of while loop, before you continue, you must always update the variable. So the correct way to write this code would be, if I mod 2 is equal to 0, then continue. Okay, so the code as written leads to an infinite loop, but you can add the update loop and then continue. So if I is not incremented before the continue, then it will lead to an infinite loop. Okay, so this is all what I had for this week. And there are certain quizzes which also involve, so you have to code a little bit and then answer the question. So the code window is given below the quiz. And so you can take a look at it and then answer them. We have a long break coming up. So one way that you can remain engaged with the course is, perhaps I can try posting a few coding questions which you can practice. There's no deadline associated with these questions, but you can use them for practice. And in case you have any problems encountered while answering, you can email me, and then I'll try to solve your coding issues. Okay, try to walk you through how to debug and so on. Okay, so I'll see you after the break. Okay, so have a good time. Bye.